Hello, welcome. This is a presentation of my homemade water splitter I call the Deuce. This is model number 11, and I'll go through basics here really quick. It's 2 cell packs in this main body of the unit here. That's why I call it the Deuce. 2, it means deuce. There's one down in there where the black is, and another one over here as well, consisting of 7 neutrals, 2 power plates, each cell pack. They're tipped up on a 10-degree angle, and the mouth of the plate cut are all lined up, giving a chute that it can, the gas that's created can exit. For an example, there's the chute I'm talking about. So, basic AC to DC converter in the back running 13.5 volts, which is the same as an automotive power supply. So this you can just plug in the wall. It's a 30 amp, and if you have to, you can clamp onto this terminal here. Red's positive, black's negative, and you could run this off of automotive power directly through jumper cables if you were needing to do that. But basically this is intended for home health gas. Gives us a water gas that is incredibly useful for an infinite number of reasons, and so I just want to make this, and it's only 19 pounds, 5 liters of water, lots of reservoir in the top here. So what I was doing before was a bit bigger of a model. This is the downsized version. I had used the original T that you can buy for the 4-inch piping to a 4-inch tower, which is that section there that's clear now. So I wanted to downsize it, put in the clear acrylic and all that stuff. So I ended up making my own T-fitting with this reducer, 3-inch to 2-inch, cutting a hole and then mounting it through. So the previous model I had just basically stuck it through and glued it in place, and it worked out fine. But there was one little problem at the end, is there was a lot of big bubble glubbing that was coming up. If you see my previous video, you'll understand what I'm talking about. But I realized that there was a big pocket of gas being created in the top of these 2 elbows before it could exit and come up. So in this one, I corrected that problem by having a smooth bubble transition. I'll show you more in a minute. I have some pictures to display what I'm talking about that. Previous one, I had a temperature thermostat controller, and it only had a 30-degree operating range, which was no good. So this time it's just a temperature gauge. That's it. Basically, the user can keep it under 60-65 degrees, and you're good to go. And I've been running this quite a bit, and it takes 3 or 4 hours consecutive runtime to even get up to 50 degrees. So it's got a long runtime for daily use. Bubbler. I've improved the bridge hose here. Much stronger connections, sealed much better. This is a check valve, so it prevents siphon back when it cools off from the bubbler. So this is filled basically to this point of water. The little hose goes down to an air stone, and that diffuses your gas. That ensures very safe gas coming out of here. Your bubbler is multifunction, basically. The new oxygen is created in this kind of harsh. So if you were to try and breathe it directly from the unit, which is never recommended, but if you did, you would probably cough because the new oxygen is 33%. And so by doing this, it diffuses into the water a lot of the oxygen. So it's much smoother coming out here. And in the unlikely event that some electrolyte might leave, if the unit gets overheated or a contamination is put in the water, some lye may actually leave, but it'll get trapped in the bubbler, and that's why I really like a big bubbler. So lots of safety diffusion there, and you don't have to change it very often. So back to this T-fitting that I created and the new modifications. I'll go to pictures in a minute. Hang on. Okay, before I finish gluing, I snapped this picture of the T-fitting. That's 2 elbows put together with a bridge piece in between them here, and then I drill through all of that with a hole cutter and stick this through. So previous, this was the reducer coming through, and I just stuck it through and glued it into place. This was with multiple applications with a paintbrush of the adhesive for PVC, which turned out really well. This is the new design here, where you see I've cut it all away and trimmed it right down flush, and I even V-grooved all of the junctions so the adhesive had a great place to settle into and do a great job of making a very strong bond. And these channels here were to prevent the bubble buildup, which ended up being a success. That was previous. And that's me starting to glue it. This is an example of the cell design inside. There's a power tab sticking up from the power plate. 4 zip ties hold it all together, and in here is Teflon line that's 4 millimeters outside diameter, so that gives me a plate spacing of 4 millimeters, which creates lots of wonderful gas. There's a power plate, and that's 2 power plates are meshed as one. That's one of the features I have in this as well, is the power plates are double thick. So I believe that will add many years of good service to this. So here's some random shots. A set, 7 neutrals, 2 power plates, for example. This was when I was cutting slots. This was a previous model. I've improved on that since. I have the laser cutter cut the slots now. This was when I was using PVC spacers cut from PVC pipe. I now use the Teflon line, way quicker. There's a bolt set up. This is how I get the positioning of the hole I need to drill through the side of the pipe. This is a helper. And there's a tool I created. It's kind of like a caliper. I stick it down onto the post, and it shows me where the hole is needed to be drilled on the outside. And there's a power post being installed, all stainless steel nuts and bolt. And this is how I make my gasket on the threaded rod that goes through the side. It's with Teflon thread wrap. I go around a whole bunch of times. Then I compress it against the pipe itself by doing it up. Then I take it back out and I wind some more around it. And eventually I crush it into place, and it's a gasket that's made in place that perfectly adapts to the contour of the pipe. And basically the gasket's on the outside. That's a bridge piece in between the elbows and such. And that's what I'm ending up with at the end, is the gaskets on the outside. And there's my power posts ready to receive the lugs that attach the power to the cell itself. I'm going to go back to the live model. Another change I did this time was, previously all the cell build-ups, I always etched the plates and rounded the edges. And I believe that was well worth the effort, but what was the difference? So this time I left the plates just as they come from the steel cutter, and it was a very interesting result. So the couple things we're going to see here is large bubble delivery instead of many small bubbles. That's the difference between the etched plate, which gives like thousands and thousands of tiny bubbles, whereas in the unfinished plate, like the untouched plate, gives large bubbles. But the good news is I haven't seen any difference in production. And also the smooth bubble delivery, because the bottom of the reducer has been carved out of the way. So, and our gauges are nice. I'll get to those in a moment. So I'm just going to click it on here. Oh, this is a grounding metal of stainless steel, and it's attached to the grounding system. So if you ever want to decharge yourself from static electricity potential, you just touch that as you are turning it on. Let's watch the bubbles here. So you can see clearly the large bubbles coming from each leg of the unit, and then a whole bunch of little bubbles start joining it. So production is excellent, super happy with that. It's running 10 amps, just a little above cold, because cold would be, I consider 21. I already ran this for 1 hour already today. So 13.5 volts, 10 amps, and it's 27.8 degrees Celsius. It can safely go to 60. It would take you a number of hours to get there. I ran this for 3 hours consecutively and I only got up to 50 degrees. So it's got lots of run time. The hose system, been working on that. I was often thinking I could change to, you know, more professional hosings and stuff, but I really like this yellow line that I've been using. It doesn't kink, it rolls up easy, it's pleasant to handle. And these guys, so I figured this out. This works really well. It's just normal 3/8 rubber hose, and it just sticks in here to these plastic elbows. So I just stick that in, just as little as that, and that's all you need. The hydrogen has to pressurize before it comes through the stone. Here we go. So these fittings also are able to rejuvenate, I've discovered, because the rubber, all you need to do is, if you're having sealing problems, as I've found sometimes, they want to dry out maybe over time. And all you need to do is rub some Vaseline, petroleum jelly on there, and then wipe it off. Just a little bit. And what it does is softens the rubber again and gives it a nice little, that's all you need to do. And it's sealed. So this gas is absolutely incredible. You bubble your water, it diffuses into the water, and you get your hydrogen, electrons, electronically expanded water. That was named by George Wiseman of Eagle Research. What it is a plasma form of water that contains electrons. So it actually energizes your whole body from head to toe. It's absolutely wonderful. The 4mm spacing that I'm using promotes more electronically expanded water to be created, because that plasma form of water is actually created between the plates, not on the plates themselves. It's in the middle, what's called the plane of inertia, and that is where this electricity is basically melding with the gas that's being created and then comes out. And I've done just basic multimeter tests on this, and yes, there's definitely energy in this gas. And myself, when breathing the gas or whatever, I can feel it. It's hard to describe. It's a little different for everybody. And you know, it's absolutely wonderful. Charges up your system. Your hydrogen helps every cell of your body. The oxygen, not so much. It's not a big deal. Basically, a lot of that's getting diffused from your bubbler. Basically turns the oxygen back into water. And but I'm sure there is some that's coming through here and then getting into this water again. It's okay. It's not a big deal. But what we're really going after is the hydrogen electrons. So yeah, so you can breathe this through the cannula. Goggles, treat the eyes, absolutely wonderful. Your eyes will immediately thank you. It's just like a big relief. It's incredible. Rubber cup, basically for knees, elbows, back and neck, or headache, or whatever. Pinched nerve, I've used that to take away pain. It's an anti-inflammatory. Works very quickly. So, yeah, the Deuce, number 11. Alright, thanks for watching. Any questions, leave a comment or email me, whatever you want, and I'm always here to answer questions. Alright, have a great day.